See, today's topic is parenteral dosage forms. Under that one, parenteral formulations. See, under the parenteral formulation, what are the different things are there? The first and foremost thing is vehicle. See, this is a vehicle. Vehicle, nothing but here majorly we can use water. See, the buffer we can use it into the vehicles. See, for what purpose we are using buffers means to maintain the drug solubility and stability. Next one is the vehicle also contains ions. What is the role of these ions means to adjust the tonicity. Next one is the vehicle also contains pyrogen. See that pyrogen can be removed by depyrogenation process. The same vehicle also contains microorganisms. That microorganisms can be removed by sterilization process or killed by using the preservatives. Next one is drug. Next one is co-solvents. So these are the co-solvents, or also we can call it solubilizing agent used for the drugs which is having poor solubility or low solubility in the water system. Next one is metals. See the glass that is made up with the alkali metal oxides. Upon prolonged storage, the sum of the metals can be entered into the drug solution, and that will causes degradation of drug. So in order to prevent the oxidation of the drugs with the help of metals, that can be prevented by using the chelating agent. Next one is the upper part is it contains the empty space of the parenteral dosage form vials contains oxygen. So in order to prevent the oxygen carried with the help of oxygen, see the oxidation carried with the help of oxygen can be prevented by using the antioxidants. See vehicle, see here vehicles majorly we will prefer the water. Some of the vegetable oils like corn oil, sesame oil, and cottonseed oil and peanut oil. See, these oily vehicles majorly used for the intramuscular route of administration. Next, some of the synthetic vehicles also there: ethyl oleate, isopropyl myristate, benzyl benzoate. Next one is tonicity adjusters. See, the tonicity adjusters, nothing but we need to make the parenteral solution should be or isotonic in nature. How can we adjust the tonicity? Nothing but by using electrolytes like sodium chloride or sodium phosphate or sodium sulfate. Under the non-electrolyte, so glucose. This glucose also we can call it dextrose, mannitol, glycerin, and sorbitol. Next one is co-solvents. In order to increase the drug solubility in the in the aqueous phase, the drug solubility in the aqueous phase in the water can be improved with the help of co-solvents. What are those co-solvents? Nothing but glycerin, polyethylene glycol, propylene glycol, ethanol. Many times they have asked in Gpat ethanol and a dimethyl acetamide. Next one is we people already know chelating agents to prevent the oxidation catalyzed with the help of metals. What are the example of chelating agent means disodium EDTA. Next one is antioxidants. Antioxidant in order to prevent the oxidation carried out with the help of oxygen atom. So what are the antioxidants? So antioxidant we can discuss in the upcoming slide. Next one is preservatives. See under the preservatives, these preservatives majorly used in case of multiple dosage forms like vials but not used in the ampoules. Ampoules we can just for single use, but vials is for multiple use. Example is phenolics like phenol, cresol, and chlorocresol. Next one is parabens, methyl paraben, and propyl paraben. Next one is quaternary ammonium compounds like benzalkonium chlorates. All these are used as a preservatives. These preservatives only we need to use in the only we can use in the vials, but not used in the large volume bottles or large volume parenterals, because in the large volume we need to have the more amount of preservative, hence the more concentrated or more amount of preservative that is toxic in nature. Next one is oxidation. See, oxidation we need to discuss under the parenteral dosage form. So the oxidation is a chain reaction. See, this carbon is reduced carbon. Here one oxygen added. Here also one oxygen added. Here two oxygens are added. Here also two oxygens are added. So hence this is a reduced carbon. This is oxidized carbon atom. See, the oxygen molecule, O2 molecule is electron deficient. See, this oxygen molecule will take one electron and will become -1. See, one of the electron that is taken here. Next, the oxygen that will take oxygen molecule that will take another electron. Hence, this is the first electron. This is the second electron. O2, O2 -2. So, oxygen is electron deficient in nature. So, oxidation is a chain reaction. Whenever it is a chain reaction, it is contains chain initiation, chain propagation, and chain termination. See, this is a chain initiation step, nothing but formation of free radical drug molecule. See, what are the three kinds of chain initiators are there? The first one is oxygen. Oxygen will act as a chain initiator. If oxidation with the help of oxygen atom, we can call it auto-oxidation. See, this auto-oxidation can be prevented by using antioxidants. If the oxygen molecule is the initiator of the reaction, we can call it auto-oxidation. See here, see this is a one drug molecule. RH is a drug molecule. This is the oxygen molecule. See, because of this oxygen molecule, hydrogen will take one electron and this alkyl group will take another electron. So alkyl group will become radical in nature. Next one is metals. See, metals also acts as a chain initiators. See here, iron is there Fe+3. This is a aryl oxy group. Here nothing but aryl oxy group. It contains two electrons. See, this iron will take one of the electron from here and aryl oxy group will take another electron. Hence, aryl oxy group will become free radical here. So, in order to prevent the oxidation catalyzed by the metals with the help of chelating agent. Next one is short UV or visible light, that is also act as a chain initiator. See, this UV light responsible for the taking of one of the electron on the OH group and one electron can be taken up by aryl group. Hence, the aryl group will become free radical. Hence, the initiation step we can call it a formation of free radical. See here, free radical. Here also free radical. This is also free radical. This is about the initiation step. Next one is propagation step. Nothing but generation of more number of free radical, drug free radical. See, this is a free radical generated from here. Free radical generated from here. That is again combines with oxygen atom. Then it will becomes peroxide radical. Again, that peroxide radical that will combine with the neutral drug molecule. Again, that will makes are responsible for the synthesis of new free radical. This is a propagation step. Nothing but generation of more number of drug free radicals. Next one is chain termination. See, the chain termination nothing but combination of one free radical with another free radical, then stopping of the chain reaction. The chain reaction can be stopped by combining one free radical with another free radical. See, this chain termination can be blocked by using the blocking agent. The chain termination can be inhibited by using the blocking agents. See, preferentially oxidized compounds, oxygen scavengers, or reducing agents. See, preferentially oxidized compounds, oxygen scavengers, or reducing agents used for the aqueous solutions. Used for the aqueous solutions. What are the examples of this one is sodium bisulfites, sodium metabisulfite, sodium sulfite, sodium thiosulfate, and ascorbic acid. All are water soluble, hence all this we can call as a preferentially oxidized compounds, oxygen scavengers or reducing agents. Next one is chain terminators or blocking agents or true antioxidants or free radical scavengers or free radical. See, chain terminators we can call as free radical scavengers. Chain initiators we can call as oxygen scavengers. All this will be act in the chain initiation. This will be act in the chain termination reaction. What are the thing used in the aqueous solutions that will be act in the initiation reaction? If you are using in the oil-based system, that will be act in the chain termination step. Example is butylated hydroxy, anisole butylated hydroxytoluene, tocopherol, vitamin E, and propyl gallate. Propyl gallate is commonly used in nature. Next one is chelating agent. It will inhibit the oxidation carried with the help of metals like EDTA and citric acid. Next one is examples of antioxidants are examples of antioxidants we have discussed. Sodium sulfate. See, sodium sulfate. The sulfate is normal, it will form sulfur normal, it will form bonds with 4 oxygen atoms. Hence, this will act as a oxygen scavenger. Here also, only 3 oxygen is there, we need to add another oxygen scavenger. Like that oxygen scavenger. Hence, the sodium salts, all these sodium salts are soluble in the water and acts as a oxygen scavengers. Next one is chain terminators. Butylated, see butylated means this is butylated hydroxy anisole. Anisole nothing but methoxy group present on the benzene. See, this is lipophilic in nature because of presence of butyl group and benzene. Next one is butylated hydroxytoluene. See, butylated nothing but these are the butyl groups, two butyl group, methyl group present on the benzene we can call as a toluene along with hydroxy group. This is also lipophilic in nature. This chain terminators used in the oil-based system. Next, propyl gallate. See, this is a gallic acid. OH, if it is OH, then it is gallic acid. If that H is replaced with propyl group, we can call as a propyl gallate. This is also lipophilic in nature. Next one is buffers. See, buffers, why we are using the buffers means to increase the solubility of the drugs at particular pH. Buffers nothing but to maintain the optimum pH of the parenteral solution that is responsible for the solubility and stability of the drugs. What are the different buffers are there means acetate buffer. If you want to maintain the pH 3 to 6 means we need to use the acetate buffer. See, acetate buffer that is contain acetic acid and sodium acetate. Sodium acetate. See, if we people have added base, then that base react with acid, then neutralization of that base will be there. Then if you people have added that will be react with salt, then acid can be neutralized here. Next one is citrate buffer. That is also maintain the pH 3 to 6. It contains citric acid and sodium citrate. If you people have added base, that base can be neutralized by citric acid. If you people have added acid, that is can be neutralized by salt, that is sodium citrate. If you people are using the phosphate, then the pH is 6 to 8 that can be maintained by the phosphate buffers. It contains phosphoric acid and sodium phosphate. If you people have used base, that is react with acid, neutralization of acid base will be there. If you people have used acid that is react with sodium salt, then neutralization of that particular acid will be there. So this is about the different formulation ingredients used in the parenteral dosage forms.